on this series to date. We've previously had ones on harmful algal blooms in lakes and as well as a well care 101. So thank you to anyone who has attended those as well. If you missed those, they're available to view in full on the Quinte Conservation YouTube channel. So if you just search that, you'll be able to find them there. I'm your host today. My name is Trent Boss from the Trent Conservation Coalition, Source Protection Region. I also have Natasha from Quinte Conservation, Kelsey from Cataraqui Conservation, and Marika from Rideau Valley. They'll be here helping out, monitoring the chat, as well as admitting the guests and dealing with any potential technical difficulties if they come up. So just a quick overview of some housekeeping items here. So this webinar will be recorded, as I mentioned, and put on YouTube in the coming days following this. So if you want to share it with any friends or family, you'll be able to do so. All participants are muted and your mics will be turned off. We'll be doing that manually if you're having any trouble doing that. So if you want to participate, you can do so through the chat function. So that you might notice there's a chat bar on the right of your Teams window. So if you have any questions, you can input them there and we'll try to get to them unless they're already included, because as part of the registration process, you may have noticed there is we're asking people to input questions beforehand. So there's a lot of questions, so we won't be able to get to all of them specifically, but we've tried to sort of consolidate similar kind of questions and ones that we kind of think are going to be most applicable to kind of the general public. So if you had a really specific question to like your own system or property, you can follow up with us in that. We might be able to help you, but we might not include that at the end. So again, so that Q&A, the Q&As will be at the end of the presentation. And if you're experiencing any technical issues throughout the presentation, you can either ask in the chat, someone might be able to help you there, or email Natasha, and her email is listed there. So we'll go through the itinerary. First of all, I'll be doing an introductory presentation on the best practices for source water protection. So we'll get to that next. And then, so that'll be about 10 to 15 minutes. And then our guest presenter for Septic Systems 101 will be Sandy Boss, who is a building inspector who specializes in sewage systems, as well as a bylaw enforcement officer for the Township of Muskoka Lakes. He's also been involved with the Ontario On-Site Wastewater Association and should be able to answer and cover any questions or anything you want to know about septic systems, hopefully. And then following that presentation, we'll get into that Q&A section that we mentioned before. So without further ado, I'll get into our best practices for source water protection. So what are the best practices for source water protection? It's essentially a voluntary ministry guidance document that aims to protect drinking water sources that are not protected by the Clean Water Act and/or a municipal source protection plan. So for those that don't know, the Clean Water Act is legislation that was enacted in 2006 in the wake of the Walkerton tragedy, where there was an E. coli outbreak in the town's municipal water supply that caused more than 2,000 residents to get sick and sadly 7 deaths from illnesses as a result of ingesting E. coli in their water. So out of that, the municipal source protection program came into place, but for years there hasn't really been the same thing for rural populations. So this document helps provide information and suggestions on how people with private systems can protect their drinking water sources on their property. So some of the advice that you'll get out of the best practices include simple and effective protection measures like testing your drinking water regularly. They recommend testing at least 3 to 4 times a year. So think of it as being sort of a seasonal test. So if you have a seasonal well on your cottage, it's recommended sort of testing it as you're setting it up in the spring and then again later on in the summer or in the fall as you're wrapping things up. It'll help you create an inventory of potential contamination activities. So look kind of documenting all of the potential threats to your drinking water. As well as implementing a protection zone around your drinking water source. So this is taken directly from the municipal source protection plan and their sort of framework. So it's creating an actual kind of imaginary zone around your well, and then you could regulate what sort of activities you want being engaged within that zone. So typically it's about 100-meter radius is kind of the basic one. But you can do a more kind of complicated scientific study if you're get a professional and you're looking at the groundwater flow, so you can get some sort of different shapes. And that's how that's something that we kind of directly taken from the municipal source protection program. Visually inspecting your well and septic system annually. Sandy will get into that in the septic side. If you're there for a Well 101 webinar, you might have learned more about how to visually inspect your well. It's looking for obvious things like cracks or any damage, any sort of like wear that looks like it might lead to any kind of contamination into your well. Pumping out your septic system every 3 to 5 years. That's something Sandy will definitely elaborate more on. And using more eco-friendly alternatives for commercial products. So this includes things like cleaning products, fertilizers, generally things that might kind of spill and leach into the soil and then potentially into your groundwater and then into your well. Or if you're on a lake and have a lake or river intake, things that might potentially leak into the body of water and then get into your drinking water. Some other things, just general water conservation. Source protection is typically more aligned with dealing with water quality, but water quantity is, of course, also something to monitor, especially during certain times of the year. Disposing of hazardous waste at the appropriate locations, so making sure you're not just keeping around hazardous waste, especially if it's in that kind of area around your well. And if needed, installing double-walled tanks for fuel storage. Fuel tanks have been a kind of a hot button topic with municipal source protection. So obviously the same is going to apply to your private wells. So just make sure they're properly inspected and maintained. And if you're on a waterfront property, keeping a land buffer to reduce surface water runoff. Again, that's another big contributor to algal blooms in lakes. Is runoff from your property into the water. So having some sort of land buffer there can help in a lot of ways. So now we may be wondering, why is it important to implement these best practices on your property? There's a few reasons that you should consider following these practices. The first obvious one is you're protecting your human health and the environment. Again, this whole drinking water protection program came out of a really tragic event that cost people's lives. So I think understanding the sort of seriousness of water contamination and that's really that should be the driving force behind this, but it can also avoid a lot of costs, like potential having to clean up contaminated sources or having to decommission and drill a new well can be really costly. Water treatment is another potential cost, but again, all these things are sort of reactionary things, but also important. General kind of maintenance can help extend the life of your system. You can make informed land use planning decisions, both on sort of where you might be building on your property or maybe even where you're considering buying a property. And in general, it just helps increase the public awareness and accountability of drinking water stewardship. So this idea that we're all sort of in drinking the same water here. We're all you're sharing your groundwater with your neighbors. So if maybe you're aware of a potential issue, let your neighbors around you know, especially if you're in an area with like well clusters or you maybe even shared wells. That's it's important to making sure it's sort of a communal awareness and activity. So yeah, this is kind of going back to the issue of that there has been a lack of source protection for rural residents. So as you can see on the left, the municipal system uses this multi-barrier approach to protecting drinking water. So water comes from the source, which is protected by these source protection plans where there's drinking water protection zones or intake protection zones and risk management plans that prevent certain activities from contaminating the source to begin with. But then that water is then taken to water treatment plants where there's going to be experts working on it and the water is tested by experts, and then it's brought to a water distribution system where there's and eventually to your tap. So along that whole steps, there's lots of experts involved in the process. But with private water, that's all pretty much gone away. It's basically coming straight from the source to you. So you really have to be that expert doing the kind of filling in those gaps along the way. So the goal of the best practices is essentially to remove those barriers that people with private systems have to provide them with a better level of resources and support. So there's all those things that we referenced earlier. And if you go to view the document, there's a lot more information and links to other resources. So if you're interested in learning more about the best practices, please contact your local conservation authority. Some conservation authorities have additional resources like a staff member to provide an assessment of your property, even to identify those potential contamination risks and provide suggestions on how to lower your risk of contamination. Depending where you are, some conservation areas may have stewardship programs and that can help subsidize some of the costs for implementing measures like such as well upgrades or decommissioning. But that unfortunately is not the case in everywhere, so reach out to your local CA and see if any of those sort of programs are in place. Yeah, that's ultimately what you want. We're trying to merge these the two systems here. Okay, so that concludes our best practices presentation. So thank you, everyone. Hope you took something from that. Again, there's links to those best practices on your CA or local source protection authority's website. So now we'll move on to tonight's expert for their webinar on Septic 101. Sandy Boss is a building inspector and bylaw enforcement officer with the Township of Muskoka Lakes, specializing in septic systems. Oh, give me 1 second. I think we might be watching some polls throughout. Sorry if I didn't touch on that. I think we'll be having poll questions, I think, after the Sandy's presentation. So if you're on a mobile device, they might pop up and block your screen, but just bear with me for a second. Computer's chosen a convenient time to somewhat crash, which is excellent. Okay, I think I've got it now. All right, do you see that, Sandy?
Yes. And thank you for inviting me, Trent, to do the presentation. And I'll go quickly through the various slides, and we'll go right through the whole system, basically right from your water source to the taps to the toilets and through the sewage system, and it'll be fairly quickly, but if there's any questions at the end to certain parts of the slides that people have questions about, we certainly can go back to them. So if we can go to the start. So let's start in the kitchen. So I think most people are aware that the source of water to the septic system is the one place that all of us can control, and that being first in the kitchen, where we're concerned about what type of products are being dumped down the sinks, whether it be bacon grease or dirty dishes, and things like Drano, for example, and any of those toxic chemicals. If you're using them, they're going directly to your sewage system and affect the operation of that sewage system. So any mistakes like that in cleaning the kitchen, disposing of food and leftover plates, use a paper towel, dump your grease into the garbage through using a paper towel. And only thing that should be going into the dishwasher is relatively clean dishes. Or if you're washing by hand, same idea. Use a filter in the sink to take out anything that's larger particles, and dispose of them in your waste bin. Obvious things to be concerned about: bleaches, worst possible, Drano, flushable wipes, anything like that shouldn't be used anywhere near a septic system. Bleach will kill the valuable bacteria within the septic tank and prevent any type of treatment within that tank, and will end up destroying your bed. And if solids are going through your septic tank and getting into your tile bed, it'll fail earlier. And I've seen a septic system fail within 4 or 5 years because somebody was using bleach to clean all their linens. Go ahead, Trent. Other things that shouldn't go down the sinks, obviously. If you're building a new house, for instance, sometimes the sewage system gets constructed first, and the drywallers, painters are all there washing their brushes in the sink. If that's occurring, have that tank pumped out before it's filled. Obviously, I've seen numerous occasions where septic system had failed, and when we were examining the bed or a tank, there was paint within the in the piping. A carburetor, one of the worst things to incorporate in your house or cottage. People think that that's a great way to get rid of potato peels or bananas or whatever. All that's doing is being ground up and put in your septic tank and creating far more solids to be building up within the tank, which means not only potential solids getting out into your bed, but also premature pumping required if you have a carburetor. So they should never be used with any type of septic system. In the bathroom, same idea. What gets flushed down the toilet, it should only be toilet paper and your waste. So so don't be dumping any of these products like feminine products or dental floss. Medicines that expired, they shouldn't be going down the toilet. So any of those wipes, diapers, cigarettes, paper towels, hair, kitty litter, we found them all in septic tanks. Condoms, you name it. Go ahead, Trent. No, it's not changing. There we go. So get to know your system, the flow of your system. Every time you flush your toilet or turn on your tap or water, where it's going down the drain and exiting the house using one main pipe. It exits dwelling by gravity, or if you have a sewage pump, potentially could be in the basement or just outside the building. That enters the septic tank and through the septic tank, which is an anaerobic treatment. Now, septic tanks aren't the greatest in treating. I mean, they've been around since the 1800s. And all you're really relying on in a septic tank is the solids to settle out on the bottom, the oils and greases, toilet paper to go to the surface and form a scum layer. The partitions, most tanks, or all tanks, at least in Ontario that are approved, have a barrier in the middle, or at least 2/3 through, where it is basically just taking the effluent from the center of the tank so that it's not taking any of the sludge off the bottom or the scum off the top and taking it to a second partition or area within the tank itself. From there, the effluent is then, the next photo is good. Go ahead, Trent. Most septic tanks are built like that, where the effluent basically migrates through a center opening in the partition and then exiting through the effluent baffle to either a pump chamber or your filter bed. Now, obviously, we're talking about on-site sewage systems. So this is not a communal type system. This would be just something in your backyard or whatever. Next slide. So that in Muskoka Lakes, the most common sewage system is the filter bed system. They're generally, like for a 3-bedroom dwelling, they're relatively small, 240 square feet, about 22 square meters in area, and they just take up a very small area. And because of that, obviously the control of the amount of water being entered into the system is important. The second slide is also a filter bed system. Now this system is partially raised. Now obviously this is partially complete. Additional stone will cover the piping, and the runs themselves, you can see, are perforated. The effluent migrates down through that piping, through the openings in the bottom of the distribution pipe and into the stone layer, down through into filter sand, and then into the underlying soils where the treatment will occur. Next slide. So there's 3 possible Class 4 systems in Ontario. The septic tank and filter bed, which is the most, as I said, most common system in Muskoka Lakes. The second would be a trench bed, which has distribution lines. Typical bed for a 3-bedroom dwelling would be 4 runs of approximately 50 feet. It requires a much bigger area, the trench bed, than a filter bed. But if you have natural sandy soils, it's probably the most common system that would be installed. The other systems that are frequently being used now, the more commonly used, are treatment units, and they include the shallow buried trench type systems and the type A and type B dispersal bed systems. I'll go into more detail about those type of systems in the next few slides. So a septic tank and filter bed system shown here is basically a distribution pipe within a solid stone area, and then the approved filter sand below that of 30 inches in depth. So it could be dug in if the natural soils are sufficiently porous enough to allow the system to be dug in, and the water table and bedrock or fine-grained soils are deep enough to allow it. There's a certain depth that they must 900 millimeters or 0.9 meters or 3 feet is required between the bottom of that stone layer to the groundwater layer, bedrock, or fine-grained soils. So in cases where your soils are in clays or other fine-grained type soils, silts, and so forth, or you have a high water table condition, the system would be raised, and then potentially a mantle area in the direction of flow would be required, the mantle area being an imported sand fill in the direction of flow. The 2 photos on the right show basically a small bed for basically a 3-bedroom dwelling, whereas that the lower right-hand side is a typical system that would be installed for a large, say 5, 6 bedroom dwelling, 3,000 square foot or more. So they take up extensively much bigger area. Next slide. And a trench bed, which may be more typical in other areas where filter sand is more difficult to obtain. Trench beds are larger area, take up a larger area, and basically the beds are excavated into trenches within, whether it be imported sand or within native sand material. And again, that area for a 3-bedroom sewage system could take up an area of 20 by 50 or so for a 3-bedroom, and much larger, obviously, for larger dwellings and more bedrooms. Now, treatment units. You have a lot. There are Trent's involved in the slides here, not me, so don't blame me. So the different treatment units that are out there, and there's been a lot more interest in them, and certainly a lot more use of them when groundwater contamination is a concern, or you're near a lake or water body where there's concerns about potential effluent reaching that water body and contaminating your swimming area. But certainly some areas where there's small lots and difficult to obtain proper treatment. There's areas where there's fractured bedrock, where limestone areas where the effluent can migrate into the underlying bedrock and into groundwater fairly easily. But treatment units are more commonly used, and these systems, there's right here, I think I've got 4 of the most common systems that are being approved. The EcoFlow system, which uses peat moss and cocoa to basically do the treatment. There's an Elgin system, the top right-hand corner. The middle left is a Bionest treatment system. The middle right is the Waterloo biofilter flatbed system. Again, on the bottom left is again a EcoFlow, which uses cocoa husks and peat moss to do the treatment. And then the bottom right is an Elgin type system that also provides the level of treatment required for to allow you in a much smaller area footprint for that type of system. Now, all these systems use basically a extended fixed film reactor type treatment. So each one of them has either peat moss, and in the case of the BioNest systems, and I do have, if we do get a chance to take a look at some of these, well, I've got some of the product here in front of me that we can have a look at perhaps a little bit later on to show you how the actual systems function. Next slide. Now, it should clarify that all these treatment systems require a service maintenance contract. So we as building inspectors, once one of these are approved, we know they're being looked after. Whereas a regular septic tank, class 4 system, whether septic tank and leaching bed system, it's totally up to the homeowner to maintain the system, ensure it's functioning properly, that they're keeping an eye on it, ensuring that whatever is going down the toilets or in sinks is not inhibiting the treatment. The treatment units, the annual maintenance requirements require them to actually carry out monitoring when sampling of the effluent to ensure the quality is meeting the standards for that type of system. And the difference in the quality of the treatment between a septic tank, as you can see with this level 1 septic tank effluent, suspended solids, CBOD, and an E. coli are very, very high. But with these treatment units, especially level 4, which all those treatment units I've shown you, they've removed the suspended solids, the BOD, as well as E. coli to far lower levels, and allowing far easier treatment within the soils, beyond the tanks, beyond those treatment tanks themselves. But I think the most important thing is these systems are being monitored, and if you are misusing as far as products that are being flushed, whether it be bleaches and so forth, they'll show up in their sampling, so it all comes back to the owner eventually if there is any potential hazards or hazardous waste or whatever getting into the sewage system. Whereas a septic tank, you'll never know whether or not that system's being misused until the system fails. And anyway, we'll talk further about that. Next slide. Septic tank, some of the newest since 2007, have added an effluent filter to the outlet of the septic tank. Now that effluent filter is not only removing fine particles before it gets out into the filter bed, but it's also allowing biomass growth on the filter itself, so that you can see the blue screen there. And if anybody's ever had a pool filter, it's kind of acting in a similar method, but the openings through that blue filter are much smaller, and you'll see a biomass growth start growing onto that filter, and over time, if it's not clean, will back up the system and potentially back right up into your cottage or house. So it has to be clean periodically to ensure it doesn't back up in your house or cottage. So I've got a little video of myself doing demonstrating how to clean it. Now, if you pump out on a regular basis and you request your pumper to clean the effluent filter, he may be able to do that for you. Or, and I suggest this to anybody, if you have your septic tank pumped, you should be there. You can talk to the pumper when he's doing it. He's familiar with the sewage system and how it operates, and generally he can tell you how well the system's being maintained, and he'd be able to provide you with a little bit of information as to how often your septic tank needs pumping, and sometimes 3 to 5 years is not enough if there's heavy use of the system. Or for a cottage use where it's only used for a couple of months in the year, it could be 10, 15 years before you ever need your septic tank pumped. Now, with the cost of pumping, you'd want to know when it absolutely needs to be pumped. And the one thing that you should be aware of, if you pump it out too often, that's not a good thing too, because the bacteria within the septic tank needs to grow. And once it's in a state of equilibrium with the bacteria, there's ample bacteria in there and it's doing its job, you go and get the septic tank pumped out, well, suddenly there's no bacteria in there anymore. And now you're filling it back up, the tank back up to the outlet level. Well, it's going to take a period of time. And from my understanding, it takes up to 6 months for that bacteria growth to set itself back into the septic tank. So you obviously do not want to pump the tank out too often because of the cost, but also because of the time that takes for that septic tank to build up the bacteria that are the good bacteria, the anaerobic bacteria that are in that tank. Now, a little bit about septic tanks and why they're not as efficient. Well, the only bacteria within a septic tank that is working is anaerobic bacteria. Well, there's not many of them, and they don't do a very good job. So the less water going through, the better they're going to work. So water use obviously is important. For every gallon of water, every liter of water that goes into a septic tank, there's a liter of water going out into the filter bed. A heavy use during a weekend, or if you have a lot of people over, sometimes it's a good idea to bring in a porta potty for that type of use, because any abuse of the system, as I say, every bit of water that comes in is going out. Now, I know some people have said, well, I'll pump the tank out before we have the wedding or whatever that may be. Again, yes, that septic tank has room to fill up over that period of time, but you've got basically just raw sewage in that tank without any bacteria within there to do the action. And over the next few days, you may be putting a fair amount of solids into your tile bed and reducing the life of it. And that would include the effluent filter. It may require more frequent clean out if there is lots of activity on a weekend or whatever that might be, whether at a wedding or whatever. So next slide. So I'm just going to demonstrate to you, that's the inlet side of the septic tank, and the outlet side of the septic tank is where the filter is, and from there it's gravity feeding out into the filter bed. In this particular case, the sewage is being pumped through a raw sewage tank, and in many cases it's a grinder pump that basically grinds up all the sewage into a big slurry and sends it up through 1.5 to 2-inch pipe up to the septic tank. So now you're sending up a big slurry of material into that first chamber of the tank. The concern there is obviously that it's not gravity feeding into that septic tank, so there's a good chance that that you're going to have far more solids in suspension going from one chamber into the second chamber, and as a result, that effluent filter may get a little overused. Now I'm having trouble getting the lid off this tank. Here we go, finally. Now you can do this on your own, but obviously you want to be very careful wearing gloves. I mean, we are talking sewage here, and you can also hire a professional to do this, but if you wish to do it yourself, be very careful, obviously, not getting anything on you, wearing now all you're doing is getting a 5-gallon pail full of water. I didn't quite fill this pail full of water in enough. Yeah, all you need to do is just rinse the effluent filter within that pail. We don't want you scraping off the little bit of biomat on there, because it's doing its job in breaking down the sewage going out into the filter bed. And then just a quick rinse into that 5-gallon pail. There's an arrow on the effluent filter. Ensure that it's pointed to the outlet. And obviously put the lid back on. It's obviously a concern that you don't want to leave that open if kids are around. This is the solid side of the septic tank that discharges up. So the first thing you want to do, if you're concerned whether or not the solids have built up into the septic tank, and you want to check it yourself, well, they actually have what they call a sludge judge to check to see whether the solids have built up in your first chamber sufficiently that it requires pump out. Now, under the building code, if the solids build up to 1/3 the volume of the septic tank, it's required to be pumped out. Now, we've found people have indicated, and here you can see in this case, this tank had been pumped fairly recently. It's fairly clear right through. However, again, this septic tank, the sewage is being pumped up via a sewage pump, grinder pump. So the effluent within that tank quite often will be in suspension and potentially getting into from the first chamber as well as into the second chamber of that tank. Now, if you don't have a sludge judge, you can also use just a stick. You can tell how deep, how much scum layer there is. Usually there'll be a scum layer of the toilet paper, greases, and that on the surface of the solid side of the tank. And when you put the stick down, you can feel the sludge layer as you go down, and you can just assess how deep that sludge is within the tank itself. Different classes of sewage system. The class 1, the outhouse or composting toilets. And I still encourage people to have an outhouse, whether at the cottage. I mean, there are guidelines within the Ontario Building Code, or requirements as far as where it has to be, setbacks that must, or water body or well. It has to be exactly 300 millimeters above any bedrock or water table. So there's a spot for it, and usually on most properties. And when you have an overflow of people, using the outhouse is always a good idea. So I encourage people at cottages to have an outhouse for those emergency situations. The other system, the class 2 system, is just for gray water. This would be just kitchen sink. If you have a small cabin, and potentially perhaps just an outhouse and a small cabin, and you have just a kitchen sink, You would have to install basically a gray water pit for that gray water. You can't disperse it onto the ground. It must go into an approved system. A class 1 outhouse system you don't need a permit for, but a class 2 gray water type system, if you are discharging gray water from a sink or wash basin or shower, it must be put into an approved gray water system, gray water pit. And again, the building code has regulations as to where it must be placed and how it's to be constructed. Class 3 system is a cesspool. Don't see them. I don't know why it's still in the building code. Class 4 leaching bed, dispersal bed. That's basically what we've been just talking about, whether it be a filter bed, trench bed, or the treatment units dispersing into type A or type B dispersal bed system. And the last class would be the class 5 holding tank system. They can only be used in situations where there's no other room for a class 4 system, and their use is not recommended. Well, they're not permitted if you have area for a filter bed or a treatment system. So they're basically just last chance type use only, where there's wells all around the area and so forth. So they're basically holding the sewage. They have to get pumped out when they're near full. They require a pump out agreement with a local hauler, and they require a high level alarm. And again, they're used for smaller properties or islands where insufficient area for a class 4 system is. The one thing that is important to note is that they're difficult for municipal systems to treat because generally it's a heavily concentrated sewage. Learn the location of maintaining your leaching bed. Well, ensure you know where all your components of your sewage system is, and the use permit from either the Ministry of Environment or your health unit or your local building department. You should have a copy, an as-built drawing or as constructed drawing showing the exact location of all the components of your system. Keep your septic tank cover accessible for inspections and pumping. Install risers if it's buried. Make sure there's an effluent filter installed in your system. Even if you have an older system, the only thing you got to be aware of is that it's got to be maintained and cleaned perhaps on an annual basis. Septic tank should be pumped out approximately every 3 to 5 years. But again, if this is just a cottage property and it's only used a couple months a year, this could be up to 10 or 15 years before you need it pumped out. And that's where it's a good idea to just check, and each time you have the tank pump, talk to the pumper, and he should be able to give you a good idea as to how often that tank should be pumped. Do keep detailed records of all your repairs, pumping, inspection, permits issued, and other maintenance activities of the system. And if you have any trouble, call a professional or call your local building department, file officer, or health unit, whoever may be the authority in your region. Common signs of system failures. Yeah, bad odor. That's always a good one. Now, the odor is sometimes a question because there's many occasions. Let me just have a drink of water here. There's occasions where if you've been away for a while and you come back and start using your system, odors can migrate from the septic tank into the piping of your inside the dwelling and out the stack above the cottage or house. And that odor, if you have lots of trees around and a downdraft can occur, you'll get that septic tank smell, that odor from the system. And it generally only occurs if you've been away for a while, or all of a sudden there's some heavy use. Because generally a septic tank, and I should point out, when I had the lids off that septic tank it's just a musky smell. You know, you don't get that real raw sewage smell out of a septic tank, and that's generally what you should be smelling out of the septic tank itself. So when you have a very strong sewage odor, it's either coming from the vent and you're either misusing your system, or you are it's just because of occasional use, you're getting that really strong septic odor. But other issues, next slide. Obviously, when you start seeing bright green grass growing in the area of your tile bed, and people think the system's functioning perfectly when you start seeing the grass growing longer where the runs are in your tile bed. Well, that's just telling you that the effluent is actually starting to surface a little bit within the bed, and the actual nutrients are being picked up in the grass. Generally, in a filter bed or trench bed system, that effluent's migrating down through the stone into the underlying soils, and very little, if any, should reach the vegetation, the grass above it. So yes, you'll see a bit of green, especially if you don't fertilize at all. There'll be a bit of green where the runs are in your tile bed. But if the grass starts getting heavier and brighter green, you know your system's getting close to malfunctioning. Obviously, if you see it pooling, that's a bad thing. When the septic tank is overflowing and your dog's all full of sewage waste, well, that might be a good time to get your septic tank pumped and your system checked. Obviously, some other concerns that we notice when doing our inspections are erosion. Drainage should be directed around your sewage system, not only your septic tank, to ensure nothing migrates into the septic tank, but also the leaching bed itself. All surface water should be directed around the bed area. It should be mounded and graded to shed the water that falls on it. The only water that should be anywhere near your septic system and mantle area is what falls on top of it. So possible signs of system failures in the future. Probably the biggest one we have in Muskoka Lakes is vegetation overgrowing over top of the bed. People do not want to cut the grass over the bed for some reason, and they let the trees grow up on it. The deep rooting vegetation, whether it be raspberries, trees growing up on it, the roots are all they're looking for is that nice rich effluent, and it won't take long for the pipes to be completely filled with roots. That's probably the most common failure that I've seen, is just from roots entering the piping of your filter bed or leaching bed system. Heavy objects over the bed area. It's probably the biggest concern is having something on top of the bed, whether it be a trailer or a trampoline or anything like that, being left over the winter. And the one thing that I've seen more often is those coveralls. People think that nice flat area where the tile bed is a good spot to plant your coverall. Maybe you've only got a trailer or something in it, whatever, but because it's covering the bed area and there's no snow cover over the bed, the frost can get into the ground and into the piping and cause your system to fail just from the frost damage. So obviously heavy objects can be also a problem. Vegetation that is allowed near or on your septic system. Well, basically grasses, anything shallow rooting is fine. I mean, I would talk to your local nursery as to some native short rooting plants in Ontario. You don't need just grass, so that it's mowed all the time. There's nice shallow rooting vegetation out there that doesn't need to be cut, and ensuring the happy life of your leaching bed or filter bed. So obviously maintaining your system and stopping it from erosion, like this one here, a little bit of erosion, keeping the grass on it, adding more topsoil if necessary, because it is all sand and can dry out. A little deeper topsoil will help keep the grass growing. I think that's it, isn't it, Trent? I think that's it. Now you're septic smart. I wonder if you can go to myself, and I can show some of the things that we were talking about before we take questions, or how are we as far as time?
Oh, we're okay. I think we can get into questions unless you wanted to. Were you going to show something?
Yeah, I wanted to show some of the treatment units out there and type of treatment systems that are out there that we're seeing being used and provide substantial better treatment than just a regular leaching bed or filter bed system. I don't know whether can people see this, or
Should be able to.
Yep.
yeah. This is EnviroSeptic instead of just piping and stone and pipe. This could be used at a cottage on an island, but it's basically provides a large area for the effluent to migrate through. There's a felt that allows the effluent to basically bacteria to grow on it and provide additional treatment, just rather than stone and pipe. This is providing substantially greater treatment before it disperses into the natural soils below it. You still have to have suitable granular soils in the system. When we were talking about the Waterloo biofilter systems, they use a foam, whether it be in a long bed type foam or in cases where they treat within a tank. The tank will be filled with this foam cubes. The effluent will migrate through the foam, and it's basically a sponge, so the effluent will stay wet inside the sponge. The bacteria grows within that sponge and provide that substantial treatment. And like a sponge, it gets to a point where it's saturated. The effluent will slowly disperse through those foam cubes and into the underlying stone layer, and then into the underlying sand fill underneath that. But the bacteria and the filtering within that foam, and again, that's using like what they call a fixed film process, intermittent filter. The EcoFlow system, I don't have any peat moss with me, but the EcoFlow system is trickle through the peat and cocoa husk by gravity, and again, the husk and the peat moss have the bacteria within them, and they're doing all the treatment before it's dispersed into the underlying soils. The BioNest system uses a tank full of like a plastic. So the tank is completely filled with this plastic, I don't know what you call it, like almost, I guess you should be able to see kind of what it looks like. And so that tank is filled with that. The bacteria will grow on that plastic fiber. Working similar to the soils, the bacteria attaches itself to that biodegradable media and eliminates the harmful bacteria. And again, it's using the extended fixed film reactor type system where it's relying on that plastic for the bacteria to grow on it, and the effluent migrating through it will attach to it. I think that's all I can demonstrate right now. So if we have questions, we can go to those.
I'll just share my screen again. So thanks, Sandy, for your presentation. So that we'll now be getting to the pre-submitted questions. I think first we might be doing the polls. Is that correct, Natasha? Just some sort of questions for our guests to help improve this seminar or webinar process moving forward. So to improve it in the future, hopefully. So
the polls are live, so feel free to answer them. It's just 5 short questions, and then just hit submit once you're done. Thank you.
Great. Give everyone little bit to complete to that, and then we'll get into the questions. Okay. So to start it off, what are the best cleaning products, soaps, laundry detergents, and toilet paper to use with a septic system?
I mean, eco-friendly products. I mean, we can all Google some of the best products out there. Obviously, anything. What they tell you is if you can't eat it, you shouldn't flush it. But you know, there's concerns. Obviously, they've reduced phosphorus in soaps. I think dishwasher soaps or detergents are the only ones that perhaps have some phosphorus still in them. But I think if you look at what the eco-friendly products, apparently the Costco toilet paper provides. I think I had some information here, but again, I was doing basically anything anybody else can do is just Google what other eco-friendly products are out there, and just be aware, read what's in the product itself. And I think some of the toilet paper, for instance, have renewable or it's not just I can't think of the name of it right now, but apparently it breaks down much easier. So I think if you look at the product and what's in it, and many of them will indicate whether they are biodegradable, that's the best thing you can do.
Sure. How do we know when it's time to pump a septic tank if it is used seasonally? I think you touched on that a bit.
I think I touched on that, and I encourage the homeowner, cottage owner, to be there when the pumper is there, and to take a look at the system. You can tell fairly quickly whether or not that system's functioning properly, and when he's pumping it, he can tell pretty quickly how deep the solids are and how thick the scum layer is. Again, be there when the pumper's there and ask lots of questions of as far as, you know, whether or not you need to pump it so frequently. Was 3 years enough? Can I wait 5 years to have it pumped, or could I wait up to 10 years before I need to pump that that tank out. The one thing to remember when having the tank pumped out is don't do it in the spring or late in the fall when you're leaving, because then that tank is empty. Common septic tank now is a plastic tank, and they will float very easy. Now I've seen concrete tanks float too if they're empty. So it's something you should do near the end of the season so that it's full before you leave at the end of your season if it's a seasonal cottage. And certainly if it's your dwelling at home, the worst case scenario would be to have it pumped early in the spring when the hot water table is high, and or in the fall for that matter. So yeah, just be aware of that concern. Obviously, if you don't have a high water table area, or you're not in a high water table area, then it's less of a concern. But as far as maintaining the septic tank, ensure you got sufficient cover over that tank. It works best when the sewage is warm. So if you have only a shallow cover over the tank of soil, and perhaps it's difficult to put additional fill over it because of it where the location of that tank is. Well, it's not a bad idea to put a layer of SM on top of the tank and then backfill over top of the SM to basically protect it from the frost and keep that tank warm. So a couple of good ideas as far as your septic tank, maintaining it, keeping it warm.
I think you kind of started answering the next question, basically. Is there anything that needs to be done to a septic system when closing a cottage down at the end of the year?
Right. So don't pump it then. That'd be a bad time because it'll be empty. So you should be having it pumped sometime during later on in the season, and ensure that if you're pumping raw sewage, or if you're pumping effluent from a tank up to a bed, that line is drained. In many cases up here in Muskoka Lakes, people will not have a valve basically stopping the effluent from backing up back into the pump chamber. That check valve should be removed or opened up with a tap type system to drain the line from the bed, to ensure that line's not full of sewage through the winter months where it can freeze and break the pipe. Same with in many cases, people will have a boathouse or a sleeping cabin in another location. Ensure that pump tank is pumped out and the line is drained from that pump chamber, so it's that line to the septic tank or bed from whatever cabin or wherever the line may be, that should be empty through the winter season. Obviously, if it's buried to a depth of over 4 feet, you have no concerns about frost, but I think that's the most commonly up in Muskoka Lakes area. That's generally pretty shallow soils, and that would be the biggest concern, is to ensure the lines have all been drained. Common way of draining them is to flush water through the system numerous times first, and so that you basically just have clear water within the line itself, and then either have a tap or just drain off the water from that pump line. And that would be the same thing you would do with any water line going to any other buildings, boathouses, or anything else. You want to make sure that all those lines are drained.
So you touched on this in regards to sort of having big events at a house, but is it okay to use large amounts of water sort of all at the same time, several loads of laundry, dishwashers, etc.?
Yeah, not a good idea. I think the most common use of dishwashers now and laundry is done over at night. Put a timer on it, whether your dishwasher or laundry. That way there's no other water use going on at the same time. Probably the worst thing you can do is have your dishwasher, you're doing your load of laundry and you're having a shower all at the same time. You can just imagine the amount of water going into your septic tank all at that same time and flushing right through. You're not getting much settlement. So dispersing the load on that septic tank over length of time is always the best way to ensure that that septic tank's operating properly.
When should you update your system or increase the size of your tank?
You're required to increase the size of your system when you add additional bedrooms, additional floor area, or fixtures. If that system hasn't already been sized to accommodate that, certainly that's not always the case where the system was oversized to begin with. But under the building code, you won't get a building permit for that addition or whatever that you may be proposing, additional bedrooms in the basement or whatever, without ensuring that the septic tank and tile bed is being sized to accommodate that additional potential load on that system. People have indicated, well, it's just the two of us. Well, if you sell the place tomorrow, then the additional 5 kids that in the family that bought your place will increase that load. So any argument about increasing or that there's very little use of the system, you know, we have no idea when that property may change hands. So the septic system has to be increased in size whenever you do anything increasing the load on it. If you have an old system, obviously anything over 40 years old, pardon me, anything over approximately 40 years old has been sized under the old EPA rules, and generally septic tanks are smaller than what they are under current regulations. The leaching bed and filter bed sizes have basically maintained the same size, with the exception of, in cases now under the building code since '98, we take into account not only the number of bedrooms, but also the floor area. Once you're over 2,100 square feet in floor area, or once you're over 20 fixture units, which is approximately 3 full baths in a dwelling. Once you get over those numbers, the sewage system gets substantially bigger with every square footage of increase in size of your building or the number of fixtures that you're adding to the property. So that's the biggest difference since it went into the building code, is that the sewage system is now based on not just bedrooms, but on floor area as well as the number of fixtures in your dwelling. So that's something to take into account if you've got an older system, that you know you'd be aware that that the current rules, your system's probably undersized to current regulations. I think the one thing that I would always suggest would be that your septic tank size is probably the real factor. So if you have a small tank, and what was allowed in Ontario prior to '98 was a 600 gallon, 2,700 liter septic tank. Current regulations require a minimum size of 3,600 liters, 800 gallons. And if you have a smaller size tank and you do have increased number of people there on weekends on occasion or whatever, increasing that size of that septic tank and not necessarily the bed area would really extend the life of your filter bed. That's where the big cost is the replacement of your leaching bed or filter bed.
So there's a question about using additives in your septic tank. Should
There's
we be
been
using?
no proof that additives do anything to increase the health of your sewage system. The probably the only additive that I've heard that has in emergency situations where perhaps somebody has killed the septic tank, somebody accidentally dumped um, bleach or whatever into the system is, and it's expensive, is that you're actually adding bacteria into the tank itself and trying to supplement what live bacteria is still in the tank itself. And that's not something you purchase at Canadian Tire or your local hardware store. You'd have to go to a specialty store that deals with sewage system products.
Right.
And again, those additives are far more expensive because you are actually adding an enzyme or actual bacteria to the system to get a kickstart the system again. So though that situation would only occur where you've been away for a long period of time, perhaps, and that everything is dormant within the tank, or somebody has accidentally spilt something into the tank, and obviously you'd want to get it pumped. If for some reason that occurred and you were aware of it, I'd have the tank pumped immediately and then add some of that product as you discharge regular waste back into the septic tank. But there's no proof on regular use of additives to a system that it does any benefit or any harm for that matter.
Okay. How do you test the efficiency of your system?
The best way to test it is obviously to check the septic tank on occasion. Now, as I said, a septic tank operating properly has just a musky smell. It'll have just small little bubbles on the effluent side of the tank, on the second chamber of the tank. You'll see small bubbles. That means there's action occurring within that tank where the treatment's occurring. On the solid side of the tank, there'll be a thin scum layer, and again, there should be relatively no odor. It should be just a musky smell. If there's a strong smell, then you're doing something wrong. As far as the filter bed or leaching bed, and you're wondering whether or not perhaps you're going to purchase a piece of property or that has a system on it, the one test that'll work for sure is to grab a garden hose and stretch it out, whether if you can make it to the bed itself or the outlet. If you got a gravity feed system, I would put it in the outlet of the septic tank, not in the. I know that some people will test a system by filling a bathtub full of water and running all the taps. All you're doing is flushing all the solids through the partition into the second chamber and seeing if you can and make the bed fill, the leaching bed fill quicker that way by getting lots of solids out into it. Easiest way to do it is to put a garden hose in the outlet of the septic tank and allowing the basically what I've done whenever I've tested a system is to take the garden hose, turn it on. You get, I think the maximum I've had was about 5 gallons a minute from the garden hose. Fill up a 5-gallon pail, see how long it takes. You can figure out pretty quickly what the flow rate is. If you get about 5 gallons a minute coming out of that garden hose, put it in the outlet of the septic tank and let it run into the filter bed. Now, if you've got a pump chamber, I don't recommend putting it into the pump chamber and just dosing the bed that way, because it's difficult to tell whether the pump's backing up or not, because the pump will run longer. But if you're able to, if there's a distribution box, and put the garden hose in the distribution box of the bed or in the outlet of the septic tank, and run it for approximately a half an hour, 20 minutes, what you're basically doing is a peak flow situation where everybody's up in the morning taking showers. And that's a quick way to see whether or not, if it starts backing up into your septic tank, you'll immediately see the water start backing up from the garden hose back into the tank. If it's within 20 minutes or so, the bed's, it's getting there. If it doesn't back up whatsoever into the tank over that 30-minute period, well, that bed's taking all the water and flushing it through the system as it should. So that's a quick way to really test the bed itself, especially an old bed or something that you're purchasing. It's a good way to determine how much life is left in that leaching bed or filter bed.
Oh. So a question about the minimum setbacks for a drilled and dug well from a septic bed to the waterfront, and trees and shrubs to a septic system.
All good questions. Regulations call for 50 feet from a drilled well, 100 feet from a dug well. Obviously, I think if you're going to drill a well or you're going to dig a well, you want it down gradient or you want it up gradient of your septic system. And here's a good diagram. So if you know the direction of flow, like in this diagram shows a water course off to the left, obviously that any migration of groundwater is towards that water course, or at least it should be. And so that setback of 30 meters is there, maintained, and there should be no concerns other than perhaps neighboring properties for that dug well. But for a dug well, minimum setback is 30 meters. For a drilled well is 50 feet or 15 meters. A water course lake is 50 feet under the Ontario Building Code, but certain lakes, certain conservation authorities, certain municipalities require a 100-foot setback for the leaching beds from any lake or water body. What was the other question?
Trees and shrubs.
Trees and shrubs. I don't know if you can get far enough away with the leaching bed from a tree or shrub. The shrubs I'm not too concerned about, but trees, I think if you're putting a new system and you got mature hardwoods, they're slow growing, and the root system's already maintained, so that setback is probably less important. New vegetation coming up around the edge of the filter bed or leaching bed, while those roots are looking for water, looking for nutrients. So if that system's being used, that's where the roots are gonna go. And I was surprised just last year, a new system had gone in it was probably only about 8 years, and I wish I had the pipe itself in the bed. It looked like it was just full of wires. The root system had migrated into the bed area, just filled all the pipes in the bed completely, and it was that those trees were only maybe 20 feet away at the most. You think that'd be far enough, but apparently not. So I guess it really depends on what your soil conditions are like. If they're shallow bedrock, well, they're gonna try to look for whatever nutrients they can get. So I don't think there's any real setback that's going to potentially save your system from failing eventually. But obviously, minimum requirement I would suggest is 10 feet to 20 feet setback to any trees, and obviously the more sun area around to the bed itself to allow things to as far as sunlight and that to get to the bed area, the better that system's going to be functioning.
So I think we're kind of discussing that here. If trees are too close, how can you address the concerns that roots may interfere with the septic system?
I'd seen, and I have no idea how well it works, but there is a filter fabric that you can put in your garden or whatever, that has I'm not sure whether whether it's whether it's a just the fabric itself is prohibiting, or whether they have any type of chemical involved in that fabric that prevents the roots from getting to the bed area itself. But I understand you can basically wrap your bed with this fabric to prevent the root system from migrating from where they are into the bed area itself. But I don't know much about it other than there is a product out there, BioBarrier or something like that, that prevents roots from getting to the bed. But other than that, just maintaining proper separation from the system, and roots, I think they're going to get there. If they want to get there, they're going to get there. So there's not much you can do.
Right. We're getting a little close on time here, but we'll try to get through the rest of these here. Septic systems installed on hard bedrock. Is that a thing?
Yeah, well, I mean, you can't build on bedrock itself. You have to have at least 6 inches of soil, and then the system would be fully raised. If you've got fractured bedrock, many areas will require you to put a clay or silt clay barrier on top of the bedrock, and then your imported sand on top of that with a large mantle in the direction of flow. I recommend that there be maintain at least some organic matter above the bedrock, because that organic matter is where the bacteria, the good bacteria, will grow and do the treatment. So you kind of want to maintain whatever type of soil there is on top of that bedrock, and then building on top of that. So that biomat itself is generally an organic matter that's doing all the treatment. So you want to have that layer above any bedrock, and just throwing sand on top of bedrock does not do any treatment. So no, it should never be built right on bedrock.
So if an older system that met the requirements at the time it was installed but no longer meets the requirements today, do I need to replace them, or are they able to continue to be in use if they're operating properly? So is there like a grandfathering system with
Yes,
septic
there
systems?
is. The system was installed and approved under previous legislation. That system can continue to be operated as is, and certainly any reinspection requirements or whatever that's carried out on your property, that system is still is still permitted. And the only regulations out there is somebody adding an additional sleeping cabin after that system was installed, and suddenly it's a 4-bedroom property rather than a 3-bedroom. That would be the only time that you would be required to increase the size of that system. But if it's approved under previous legislation, it's grandfathered.
So if you do need a new system,
there is no typical.
right?
Again, if you've got existing granular soils there and the system can be installed directly into and very little imported fill needs to be brought in, then obviously the cheaper the system. I really wouldn't want to throw numbers out there, but I would say anywhere between 50, what I've seen as far as systems being installed, anywhere for a small property, for a small house, 3-bedroom, anywhere from 15,000 to 35, 40,000, depending on whether it was native soils there or whether everything had to be imported. Obviously, for the bigger places, probably the most I've seen was $200,000 on a sewage system for one of these huge cottages in Muskoka Lakes.
Well, is there any paperwork that the owner should be keeping in regard to?
Oh, well, I mean, obviously the use permit is the most important thing to keep. And if you do not have a copy of that use permit, contact your local health unit or building department, whoever looks after you. They should have a copy of it, and maintain a copy. If you ever sell the property, you're going to need it. So you should have that. And any as-built information as to how that system was constructed, whether the installer provided you additional information on what was installed, maybe the bills of the septic tank and the bed itself. All that information is valuable for future.
Well, great. I think that comes to the end of our pre-submitted questions. So thank you, Sandy. I'll throw it over quickly to our moderators, looking at the chat if there was anything, questions that weren't addressed during the presentation or Q&A section.
Yeah, so there were a few questions that weren't addressed. Do you have a couple extra minutes there, Sandy? I know we're just over 8 o'clock.
I'm here all night. Yeah.
Awesome. All right. So one of the questions that was asked was, if you can't use Drano to unclog your system, what should you use?
Well, there is. I was going to bring one in. It's basically like a strainer that you can put down through the pipe. Like all plumbing should have a clean out at the bottom within your sinks. So that would be the first thing to do, is put a pail underneath that clean out, undo the little valve that there is under it, and anything that's stuck within that clean out area should come out then. And they do make a long, flexible with little rough edges on. I don't have a name for it, but I'm sure if you go to a hardware store and ask for it, most of them will have it. But basically,
they call them drain snakes usually.
It's kind of a drain snake, yeah, and it's only maybe 1.5 feet, 2 feet, well, probably close to 2 feet long, and I've used it myself, and it works perfectly. And you know, you should never have to use if you're using your sinks properly and you have a good strainer, you shouldn't ever have to deal with it. But on occasion you need it. But that's probably the best product I've seen that works perfectly well.
Wonderful. Well, thank you for that. Another question was, is it good to add yeast to your system?
Again, that would be something like some of the products that you purchase at Canadian Tire or any hardware store have yeast in it. And again, there's no proof that they do any benefit.
Awesome. And then one last one was, if you have a water softener, should you discharge that into a separate dry well or something similar?
If it's possible to put it into a separate dry well, it's highly recommended. I think most concrete manufacturers indicate that additional salt, let alone the additional water during when it's flushing, does break down the concrete. And I think that's the one thing about the concrete tanks that I've noticed, the older ones, depending on, I guess it depends on the batch that when they were making that tank, but an occasion that concrete will just completely deteriorate. And apparently the concrete manufacturers indicate that salt from the discharge will increase the decay of the concrete. So no, if it's possible not to discharge it into the sewage system, that's the best thing, let alone some of the older ones. And I guess it depends on the water quality that you're drilling coming from your well. But there's a lot of, in some occasions, there's a lot of water being discharged into the septic system when it backwashes. And I would personally not put it in. I would do whatever I can to discharge it into a dry well or just outside. There's no regulation that stops you from discharging it under the ground surface. So I guess as long as you're not discharging it directly into a lake body and directing into a ditch, or a dry well would be the best. place for it. But that's what I would recommend. I know one of the treatment systems that are monitored on a regular basis, they had to get the backwash water discharged somewhere else because it was causing the system to trigger an alarm. And again, that's the good reason why you have a treatment unit, because they monitor it, and it was telling them that discharge water from the water softener was killing the system.
Yeah. Awesome. And then, sorry, there was one more question, and I believe it was, I'm just going to pull it back up here. Is it possible to install a backwater valve to prevent effluent going back into the house?
No, I haven't heard that one. I mean, I think it's a requirement for municipal systems. Excuse me. Yeah, that's a good question, and I can't say I would know. I think that'd be a plumber's question whether that's possible, whether they could. I can't see why they couldn't. But I mean, if you install it, then the only thing that's going to occur is that you're going to end up seeing you're discharging the water in your septic system, and then probably the best thing you can do is have an alarm, and that's something I didn't touch on during this, is that all new systems have a high level alarm required on any pump chambers, and if they're, so that you're alerted that your pumps failed prior to it backing up into your house or cottage. So it's a requirement on all new systems that's being installed. But if you're really concerned about backup, that would be the thing to do, is to have a high level alarm. And you could actually install one in the septic tank. And that would tell you fairly quickly whether your bed's starting to fail or not, is you could put a high level alarm in the septic tank itself. And once it starts reaching above the outlet of the tank, before it starts backing up in the house, that alarm will go off. So that's probably what I would suggest being used, rather than the other way around.
All right. Well, I think that's the end of our questions. If you didn't get a question answered, just let us know. You can email us. Our emails will be on the next slide. But we just want to say thank you so much, Sandy, for providing all this valuable information. I think it went over very well, and everyone learned something new. We do have our next webinars coming up in the new year, so we're off for the holidays for now. But our next one will be on January 25th, and it's going to be about realty and rural drinking waters. I believe Kelsey just put in the chat that our emails and the links to the next registry. So without further ado, I think it's a good time to say good night, and thank you everybody for attending our webinar.
Well, thank you for allowing me to let everybody know what I think about septic systems. Thank you.
Great.
Thank you,
Sandy.
Sandy. Thank you,
Thank you.
everyone.